Students, in this video, I want to talk about greenhouse effect and the term global warming. Now, when we think about greenhouse effect, it is actually a process that's critical to our planet. We need this effect to occur. So, one thing that you hopefully know that is involved in the greenhouse effect is carbon dioxide. And what's the big deal about carbon dioxide? Well, it plays vital roles in our environment. It absorbs infrared radiation in the atmosphere. So when the sun emits infrared radiation or the solar radiation that eventually hits the Earth's surface, what happens is it warms up the Earth's surface and then it reflects this heated light and infrared heat. Okay, and so I'll go into this a little bit more, but we definitely need to know that it absorbs infrared radiation in the atmosphere. It helps weather our rocks, which we need our rocks to break down because there's a constant cycle. It's the raw material for photosynthesis, and we find it in organic matter in the biosphere, and eventually it is stored in Earth as fossil fuels. Now, let me pause here for a moment because I need to make sure that you understand fossil fuels. What is an example of a fossil fuel? You hear about this all the time, but let's make sure we understand it. So let me go to this page. So like coal, oil, and natural gas, these are the three types of fossil fuels. They were formed from layers of dead organisms over millions of years ago, underground. So if we could go back millions of years ago, there were trees and there were living organisms. They were not humans, but eventually trees and organisms, they have a lifespan and they die. And let's take, for example, a tree. The tree doesn't live forever. It can basically stop living, and then it falls to the ground and it decays, and then we get this layer of sediment that presses on top of it, and it eventually is layers and layers in our Earth. Okay. So, however, oil and natural gas are formed underwater from dead marine organisms. After they decompose, they are superheated from pressure and accumulate in a reservoir of sandstone, limestone, or dolomite. So here is some examples of how what's happened here. So in the ocean, 300 to 400 million years ago, tiny sea plants and animals died and were buried on the ocean floor. Over time, they were covered by layers of silt and sand. Over millions of years, the remains have buried deeper and deeper. The enormous heat and pressure turned them into oil and gas. Okay. And so today, what happens is we drill down through layers of sand, silt, and rock to reach the rock formation that contain oil and gas deposits. So this is an example of us drilling into the earth and extracting these oils and gas, and coal is what we get to. And we use all three of these sources as a source of energy. You possibly can't charge your phone without have had using fossil fuels. You cannot drive your car without have had using some sort of fossil fuel. Now, even further, a lot of our products, like your computer, your telephone, your table, your cabinets, your toothbrush, they use some sort of oil that created the plastic that our products are made from. So we absolutely can't get away from fossil fuels. We are very dependent on it. Okay, so fossil fuels, again, are either, we can talk about coal, oil, or natural gas. And we extract it from the earth that was created millions of years ago, and we use it for a source of energy. And mind you, there's only so much of it in the earth. It's not infinite amount. All right, so now that you have a good understanding of fossil fuels, let me go back to our greenhouse effect. So most of the sun's energy that falls on the Earth's surface is in the visible light portion of the electromagnetic spectrum. And you learned about the electromagnetic spectrum. This is a large part because the Earth's atmosphere is transparent to these wavelengths. Part of the sunlight is reflected back into space, depending on the albedo or reflectivity of the surface. So it depends on where it hits on the surface if it's going to reflect back into space. But not all of it does. Part of the sunlight is absorbed by the Earth and held as thermal energy. This heat is then re-radiated in the form of longer wavelength infrared radiation. While the dominant gases in the atmosphere, nitrogen and oxygen, so what that means is truly the most abundant gas in the atmosphere is actually nitrogen and oxygen. Okay, but they have different purposes than what the greenhouse effect is. They don't really have anything to do with it. They do other things for our planet. So the so-called greenhouse gases, which are primarily water vapor, which is H2O, CO2, carbon dioxide, methane, CH4, absorb some of that infrared radiation. They collect this heat energy and hold it in the atmosphere, delaying its passage back into the atmosphere or into space. So let me show you what that looks like. So we get the solar radiation from our sun. It comes in, passes through our atmosphere, and hits the Earth's surface. It warms up the Earth's surface and re-radiates back into the atmosphere. And here's an example, this red line. And greenhouse gases such as water, CO2, and methane, they capture that infrared heat and hold it in the atmosphere. So they're holding heat in the atmosphere. Well, so why is this important? Well, you can think of it like this. They're like a blanket in our atmosphere, a blanket that holds in heat for our planet, for all living things to thrive, and for our water to be in a liquid form. It's like a Goldilocks effect. It keeps our planet the right temperature for us to thrive and live. If we were to compare this to another planet, let's compare it to Mars. We know Mars does not have human beings, or they're not living there. They don't have vast oceans or lakes. They don't have trees, bushes, grass, animals. They don't have any form of living organisms. Their atmosphere is not like ours. They don't have this lovely blanket of greenhouse gases that they trap in that heat and hold it there to keep the earth warm. Now, think of it like this. When you go to bed, you put a blanket on you. Why? Is because when your body radiates heat, it stays between your body and the blanket. right? The blanket is trapping in that heat so you stay warm at night and you're comfortable and that you sleep well. So our greenhouse gases, water vapor, carbon dioxide, and methane, that is what they do. They trap in that infrared heat that was radiated back from the Earth's surface, and they hold onto it. Now, let me talk about this word global warming, or you hear either global warming or climate change. And what is that saying? Well, it's saying that there's something going on with our greenhouse effect. It's imbalanced. And what that means is somehow we're inputting more greenhouse gases into our atmosphere, more than we need. We need just a certain amount, not a ton of it. And so we're putting more CO2, for example, from burning our fossil fuels. When we use something, we're burning fossil fuels and it emits more CO2 into the atmosphere. That's just an example, and I'm going to stick with CO2 for now. So if you're putting more CO2 molecules throughout the atmosphere, well, they're just going to do their job and they're going to go ahead and trap in more heat. So it's like you adding more layers of blankets at night. You're going to trap so much heat, you might get hot in the middle of the night. And so that changes the temperature of our planet. And it has effect on systems, our atmosphere, our biosphere, our hydrosphere. All those spheres, which are systems, have an effect on when our greenhouse effect is imbalanced. All right, I hope that this information helped you better understand greenhouse effect, global warming, meaning that it's changing our weather patterns, for example, because we're just getting more heat in the atmosphere. And so things are unbalanced. We need things to be just right. And then, of course, hopefully you have a better understanding of fossil fuels.